Hi, Carl. If it's okay, let us start the session.
Yes, yeah, happy to work away.
Let me introduce Neelima to you, who will be hosting you today.
Perfect.
So welcome, Neelima.
Hi. Okay. Good afternoon, everyone. Welcome to yet another exclusive webinar on Avalanche Blockchain ecosystem and overview and L1 blockchain deployment. And before we introduce our speaker, we have a couple of announcements for all of you. So we'll be glad to share with you a blockchain-powered certificate and this to appreciate your successful participation to this session. And for this, you just need to fill a Google form where you have to give your feedbacks that will be given to you at the end of the session. And we also have an exclusive Q&A session where you can raise your queries or doubts to the speaker. So with no further ado, let me invite the speaker of the day, Carl Timmins, who is the Irish ambassador at Avalanche Blockchain, and he's also the senior application development specialist at Accenture. Over to you, Carl.
Thank you so much, Nilima and Arya, for putting this together. Let me just share my screen here quickly. Everyone can see that, yes?
Yes, yes.
Brilliant. Okay, so hello and welcome to the Avalanche Ambassador DAO subnet deployment and ecosystem overview. So who we are, I'll give a brief synopsis on what we're trying to achieve here. I'll give a brief overview of blockchain. I'll give a brief overview of Avalanche, and then we'll go into kind of the finer details of Avalanche and deployments within that. So I'll share some resources then at the end that can help students and individuals who want to participate to the network start their journey to become more involved with Avalanche. So we are the Avalanche Ambassador DAO, and we are here to showcase the benefits of the Avalanche blockchain and some of the use cases it can excel at. We have recently begun our operations here in Ireland with the intended goal of creating a community of not only developers, but people from all walks of life who are interested in working with and around blockchain technology. So looking at exactly who we are, so we have Eamon Dean, who's the head of ambassador program at Avalabs. We have Shweta Rahill, who's also an ambassador here in Ireland. And myself, Carl, as mentioned, I'm a senior software engineer at Accenture and also the Irish ambassador for Avalanche within this country. So I do a lot of personal development. I build a lot of applications, that the decentralized applications. I take part in a lot of hackathons. I do a lot within the community. I run events here in Ireland and abroad, as we can see here. So looking then at a brief history of blockchain, the concepts of blockchain were first introduced in 1991 by Stuart Haber and W. Scott Stornetta, who proposed a cryptographically secure chain of blocks to timestamp digital documents. In 1992, they incorporated a Merkle tree to improve efficiency. Then in 2008, an anonymous personer group under the pseudonym Satoshi Nakamoto published the Bitcoin white paper, introducing blockchain as the underlying technology for Bitcoin. This was the first decentralized blockchain designed to enable a secure and trustless peer-to-peer digital currency system. The Bitcoin network went live in January 2009 with the mining of the Genesis block. So what Bitcoin did was solve the double spend problem online and also the Byzantium consensus protocol. It resolved two issues with digital spending online. So then in 2013, Vitalik Buterin suggested Ethereum. He proposed that. He was working for Bitcoin Magazine, if I'm not mistaken. Basically, Vitalik Buterin proposed a blockchain platform that expanded the use of blockchain beyond cryptocurrency by enabling smart contracts, which are self-executing contracts with predefined rules. Ethereum went live in 2015 and introduced a new era of decentralized applications, dApps. Then looking further beyond that, we have the enterprise adoption on private blockchains. So during this period, enterprises began exploring blockchains for use cases like supply chain management, finance, and healthcare platforms, such as Hyperledger. Initially, and then we had Corda, developed by OR3, were introduced, focusing on private permission blockchains for businesses. So blockchain technology is evolving here as we're kind of coming through the 2010s. And then in 2019, we had DeFi and NFTs, big hype around that. So blockchain evolved with the rise of decentralized finance, offering financial services without intermediaries. NFTs also gained popularity as unique digital assets on blockchain, revolutionizing art, gaming, and collectibles. And then from 2021 to kind of now, we've been looking at blockchain 3.0 and scalability innovations. So that's something that Avalanche really looks to address, is the scalability, high throughput, and time to finality, short time to finality. So the focus shifted to improving scalability, interoperability, and energy efficiency solutions like proof of stake, sharding, and layer 2 scaling technologies, such as the Lightning Network, Polygon, for example, emerging to offset computations from the main chain, using Ethereum as the example, to allow for roll-ups and things like zero knowledge proofs to be enabled on layer 2 scaling solutions. So Avalanche looks at a different method to allow for scaling. So they create a lot more validators and then break up the consensus so that we can allow for multiple lanes of traffic to go through Avalanche. So I'll go into more detail about that now shortly. So looking at the Bitcoin timeline, we have 2008, Satoshi Nakamoto, an anonymous enigmatic figure, or a group of individuals, releases the white paper called Bitcoin, a peer-to-peer cash system. Then in 2009, Bitcoin is first mined in January by Nakamoto. Other miners, though their numbers are small, soon follow. Then in 2010, we have Laszlo Haisina, who goes by the handle Laszlo, exchanges 10,000 Bitcoin, valued at the time of $41 or 41 cent per Bitcoin, for 2 Papa's John pizzas. So the first spend of Bitcoin happens in 2010. Then we have 2011, the value of Bitcoin rises to $1 for the first time, and by the end of December reaches more than $13. So good time to be involved in Bitcoin 2013. And then 2021, El Salvador becomes the first nation to make Bitcoin legal tender. Its holdings turn a massive profit for the Central American country by March 2024. And 2023, then the IRS uses the term digital assets in place of virtual currencies, a term used in previous years to refer to Bitcoin and other cryptocurrencies. So you can see from inception, 2008, 2009 to now, how the ecosystem and even the approach or kind of thinking towards Bitcoin from institutions and the perspectives have changed, and it's ever evolving. So kind of anticipate that continuing and becoming a lot more accepted and a lot more prevalent in, let's say, financial services, medical data, all walks of industry. So then looking at some of the technologies specifically around blockchain. So some of the technology there, we would have smart contracts, layer 2 solutions, consensus mechanisms, and decentralized identity. And then some of the financial innovations that we have related to blockchain would be cryptocurrencies, DeFi, decentralized finance, NFTs, CBDCs, and then tokenization of assets. So a lot of innovation has been created through blockchain alone, and through integrating blockchain into society and industry. So again, anticipating more to come, and specifically around Avalanche, we are looking at developers providing these innovations within the ecosystem. So I'll mention it later as well. But for example, EVMs, we're looking to be multi-chain, and we achieve that through the creation of EVMs. So we're chain agnostic nearly to an extent. We would have Solidity smart contracts on Avalanche, and we would also allow for EVMs to be created to interact with other chains. So I know Martin Urquhart was mentioning that the creation of Solana EVM, for example, is something they would like to see, so that Solana can interact with Avalanche. So if anybody has that kind of wherewithal to push, or a group of people to create an EVM, the Avalanche are very open to that type of integration. So then, looking at a brief history of Avalanche. Avalanche is a blockchain platform launched by Aval Labs in September 2020. It was designed to address some of the scalability, security, and decentralization challenges faced by existing blockchain networks. So Avalanche was created, as mentioned, specifically to look at industry specific problems. Excuse me. Avalanche will what was proposed, as we'll see here, in May 2018. White paper is released. Then in 2019, Aval Labs was founded. In April 2020, Avalanche's testnet called Denali goes live. And then in July 2020, the ICO was launched. For those who remember ICOs, big part of crypto for a long time, where you could basically, it's still around, but not as prevalent at the moment. You could it's like an IPO where you could purchase into the actual launch of a coin and get in early. So then September 2020, mainnet officially launched. And then in 2021, several milestones were achieved with regard to research and deployments. And then in 2022, network development. So a lot of focus on developing Avalanche network. Excuse me. Deploying smart contracts, deploying functionality within the network, and ensuring that that high throughput and time to finality is launched on the network. And then 2013, continuous development, so ongoing. So for example, in the end of 2024, we had the Etna upgrade. So the Etna upgrade changed the consensus method, and also the amount of staking that it would require to be a validator, and also allowed for higher throughput, and more more transactions per second, and again a higher throughput and time to finality. So I think Avalanche, and again this will come into it later, about 2,500 transactions per second, and we envision that increasing. So to be able to compete with the likes of Visa and MasterCard or any other provider, you need to be able to scale to allow for adoption. So yeah, we'll go into that further. So then in 2024, the Avalanche Ambassador DAO was launched, and that's what I'm a part of here now to promote Avalanche and encourage people to get involved with the development on the main network. So let's look at some of the architecture specifically around Avalanche. So there has been multiple generations of blockchain. So as mentioned previously, Bitcoin was the first real blockchain with one asset. Zcash, similar, but blockchain or Bitcoin was the first. So one asset, one on Bitcoin, so one blockchain. So first generation, single chain, single asset. And then we're looking at the next iteration, which is, as mentioned, Ethereum started in 2013, I think its inception, and launched in 2015. So then second generation, single chain, multiple assets. So Ethereum introduced the capability to have a diverse set of assets on a single chain through different smart contracts, multiple assets available, NFTs, real world tokenization of assets. So you have one chain with multiple assets, as mentioned. So you have a lot of smart contracts allowing for the tokenization of paintings or NFTs or cars or homes, things like that. So again, the evolution of blockchain and the allowing of multiple assets to be brought in. So we envision this continuing. Then we have the third generation, which is multiple chains, multiple assets. So for example, Avalanche, Cosmos, Polkadot, layer 3s, networks of interoperable blockchains. We can now have specialized blockchains. Motivation for specialized blockchains would be that they're economical. Some solutions are not economical on public chains, too high gas fees, for example. So it doesn't make sense. So the low gas fees are something that we focus on in Avalanche to ensure that, you know, as a business, you don't have to worry about spikes in gas fees. And again, we will go into this shortly. And then compliance, regulatory restrictions, KYC, AML. For the KYC is know your customer. So I worked in banking for a period. So KYC and AML is a huge factor within financial services. So anti-money laundering. So is an individual who's coming onto your chain, are they looking to launder funds? Are they looking to use your chain for illicit activities that could get you in trouble with regulators? So a huge focus and point of importance for any institution coming onto the chain. Is like, are they reputable on that chain? Am I coming onto a chain where there's going to be a scandal and, some country or foreign entity or individual is going to be associated with that chain, which is going to then bring down the reputation of the company. So Avalanche looks to address all these issues, and through the creation of layer one blockchains allows for a seamless process. You can create your own layer one blockchain on Avalanche, and then you can create all the stipulations around that. So you can have you know validators only in specific regions. You can whitelist people, you can blacklist people, things like that. So it's a very versatile and robust chain. So then Avalanche is building architecture to be independent, scalable, and compliant. So that's the focus of Avalanche. And as we can see, as I mentioned, the evolution of chains here. So we'll look at some of the performance metrics around blockchain. So we can use this analogy of lanes of traffic. So as we can see here, you have one lane with a transaction, another lane with a transaction, another lane, two transactions. Let's just assume they're all traveling at the same speed. What would affect speed would be gas fees, the amount of fees that you put to the transaction, which would increase the speed of that transaction. But we can look at the wallet interface here. This is the core wallet on Avalanche. Again, I will provide resources to allow individuals to download this. So you send your transaction, you hit confirm. I'm sure if individuals use MetaMask, same thing. So you hit confirm, transaction is sent through these lanes, and then finally ends up in finality. So or on the blockchain explorer. So this is how you can assess how good a blockchain is, or the health of a blockchain, how fast it can get transaction from A to B, and the cost associated with that. So yeah, we can base performance metrics of a blockchain associated with the amount of transactions that can reach their destinations fastest. For example, individual representation here, we can see the beginning of the process is the interaction with the user's web wallet, passing through multiple lanes with low conjunction and reaching finality quickly. So Avalanche has a time to finality of less than a second, which is really impressive for a blockchain. Other blockchains don't have that functionality. And this is the architecture of Avalanche with multiple validators and chains running to ensure multiple lanes are available to users. So we'll use another analogy here. So we can see from, let's say, from Istanbul to Tokyo, we have a direct route. So we have multiple lanes here, which is allowing for the shortest time to finality and high throughput. Now we can see if we veered off and went on a very roundabout route to Paris on the way to Tokyo, it's going to take a lot longer. It's going to be a lot more of a roundabout route. So a lot of blockchains actually take this approach. They initially they would have taken this, and they're making improvements to ensure that they get a more direct route. But Avalanche from its inception identified this issue, and has a very direct route to finality. So this is one of the most important pieces around blockchain and let's say industry adoption. So throughput, how many transactions are finalized per second, measured in transactions per second, or TPS. And then time to finality is how long does it take a transaction to go from being submitted to validators being unchangeable. So how many validators once the validators confirm it, that's confirmed, and it's immutable. So these metrics are very different. Blockchain builders aspire to have high throughput and very short time to finality. Let's take the analogy again of the highway here, where each car represents a transaction and they all travel at the same speed. Throughput could be likened to the number of lanes determining how many cars can pass on the highway in a given amount of time. The more lanes you have, the more cars that can pass through, thus increasing the throughput in a blockchain network. Increasing the block size, analogous to adding more lanes, can increase throughput. Now, what Avalanche will do is increases the amount of validators and their own specific layer ones, allowing for that kind of a DAG network, directed acyclical graph to allow for high throughput. Now, imagine you're driving to a specific destination, finality. The time it takes you to get from your starting point, initiation of the transaction, to your destination, confirmation of the transaction, is analogous to the time to finality. As soon as a car reaches finality, it cannot return or abort the travel. Our goal is to build highways with many lanes, high throughput, that bring us to our destination as fast as possible. So that's really what this is trying to represent. It's like we want multiple lanes, which are multiple validators, and the transaction to get from A to B as fast as possible. So that's what we are achieving. Avalanche is doing that very well. So in comparatively speaking here, we can look at, as can be seen in this diagram, we have a visual representation of the idea of transactions per second, which is possible as chains have iterated. So Bitcoin here, I think Bitcoin's about 6 to 8 transactions per second, and it's 60 minutes to finality. So although Bitcoin is a great technology and a great asset, there are some challenges with, let's say, widespread industry adoption of the technology. So having only 6 to 8 transactions per second and 60 minutes to finality is probably one of the reasons why a lot of people say it's more comparable to digital gold rather than, a financial system. Because you couldn't have 6 to 8 the congestion would be like if the world was trying to transact on that, it just wouldn't work. Ethereum is set to 12 to 15 transactions per second, and about 13 to 20 minutes for time to finality. So an improvement on Bitcoin, but still not although decentralized, not allowing for industry adoption, and it's not enough. Avalanche, 2,500 transactions per second and below 1 second time to finality. So as mentioned, and as we can see here with the lanes of traffic, huge throughput, very short time to finality, and Avalanche is increasing that. The intention is to increase that through adding multiple validators, and expanding the amount of people that are actually validating on chain and the amount of layer ones that get deployed. So the more validators we have on chain, the more transactions we can put through, the faster time to finality. So that's the approach here, and again, it's iterative. We have seen the technology of Bitcoin moving to Ethereum, and then Avalanche really expanding on addressing the challenges faced by the blockchain industry. Excuse me. So we can look then at how the architecture of Avalanche is set up with layer ones and subnets. So you have the primary network, and then validators within each individual set of let's say networks. So these have actually changed to layer ones rather than subnets. The actual naming has changed. So we'll see now here. So you will have a primary network, which is wrapping the validators within the network itself. So you will then have a subnet within the primary network, which would be deployed by an industry, or at the end of this, we're going to go through deploying your own layer one, which would be then, once you go live, you'll be able to participate to validation through staking of AVAX or using AVAX itself, which has recently changed as part of the upgrade. So you would then have a subnet 3, for example, which is again providing validation to the network, and then another subnet 4, for example, which is creating this mesh network or DAG within the primary network. So that approach to consensus and validation allows for huge throughput, as mentioned, the 2,500 transactions per second, and low short time to finality, which this is the secret sauce of Avalanche here, and that's what allows for the mass scalability of the network. So then this is again just a separate version or visual representation. So we have massive combined throughput of the subnets allowing for multiple lanes. So like one network here is allowing for multiple lanes. You combine this network to allow for another set of multiple lanes, more traffic, low congestion, high throughput, low time to finality. So the more layer ones that we have on the network, the more transactions we can get through. So this is, as mentioned, as part of the Etna upgrade, where we've just changed the naming really to layer one from subnets, and short time to finality here. So it's short from A to B, and multiple lanes. So yes, so with the Etna upgrade, some nets became their own layer one. Instead of using a subset of primary network validators, new layer ones can now use a distinct set of validators. This change maintains the short time to finality and high throughput Avalanche subnets are known for, while also enabling a new set of features with options for completely customizable staking options, gas tokens, and governance. So out of the box with an Avalanche Layer 1 deployment, you're going to get the option to customize your EVM. So you're going to get, as mentioned, KYC options, airdropping of tokens, whitelisting, blacklisting. The list goes on. There's multiple options that you can have when you're creating your Layer 1 blockchain on Avalanche. So I'm going to provide at the end of this, excuse me, a starter kit for each person attending, where you can actually deploy, and I'll go through the deployment to show you how quick and easy it is, and you can start to develop and deploy your own blockchain. So that's quite an enjoyable process. So then looking at some of the issues around adoption with other chains as well. So we have fee isolation. So as you can see here, this mightn't be super clear, but you can see spikes here in gas fees, right? So if you're a business and your margins are thin, right? So you mightn't have, 200% margin, you might be working on a 10% margin or a 15% margin, and that's your revenue. You cannot operate if your fees are going to spike over periods. So you're 24/7 business, you're working digitally online, and then just, between July 20th and 22nd, the fees just spike, 200x, 300x. How do you operate? Like, do you just say, oh, we can't process transactions then? Your margin, those days of working are completely gone on fees. So it's really challenging to allow that to happen on a chain, or if you're a business, you're going to look at that and say, well, why would I do that when Visa or MasterCard are flat fees, or I can anticipate and I can account for fees. I can do assumptions based on that. I can't make assumptions in an accounting from an accounting perspective if my fees are going to spike dramatically and then decrease and up and down. From a business perspective, it's not how you want to operate. So that's something that Avalanche has looked to address within the blockchain itself as well, to make sure that fees remain constant or very little fluctuation over time. Higher transaction fees make the and variable transaction speeds make it difficult for businesses to adopt blockchain technology. It is one of the main issues affecting wider adoption of the technology. So again, not only the cost, but the amount of time that it'll get through. So like when you're talking about this transaction, during this period when the fees have increased and you're just sending your regular fee, it's going to take a longer time to actually hit finality and reach its destination. So again, you could be waiting for critical infrastructure or critical aspects of your business, and your payment hasn't received for an hour, and you can't operate. So it's not how to operate a business. So as mentioned, Avalanche looks to address this. So then customizability. As I mentioned previously at the start, we are EVM agnostic, and we can allow for the creation of smart contracts written in Solidity. Not only that, so our consensus goes across all the EVMs. So as an institution, if you want to adopt Ethereum as a technology, and you would like it to perform in a specific manner, to meet your business needs, you will need to go through a lengthy process to firstly submit a proposal to the community. So and push for the proposal to be adopted. So really, if you adopt blockchain technology, if you're a business and you're coming in and you say, right, okay, I want to start, minting NFTs, or I want to start recording all my transactions on a public ledger or a private ledger, even to that matter. You want to adopt, let's say you think, oh, Ethereum, or you're doing your investigation as to which is the most relevant blockchain to take across, like you would, with a database. So you might say, okay, well, will I take MongoDB? Will I take Postgres? Will I take, any number of databases that you could choose from? Same with assessment you would kind of do with blockchain. So if you wanted Ethereum to act in a certain manner. So if you wanted, for example, only your transactions or your validators to be available in India, say, for example, medical records, you've got specific data. In Europe, we have GDPR, which allows basically data protection rights, but it would mean that medical records can only be processed within Europe. So if you're an American company, you can't process that relevant information in any of your multinational organizations or regions. You'd have to have that been processed in Europe. So if you take on Ethereum, for example, and you say, oh, I would love for this feature to be available, because I can't adopt your technology unless I can ensure that the relevant information is only processed in a certain region, you would have to, propose that solution to the Ethereum Foundation and the community. You'd then have to drive that within the community. You would have to, push for the adoption, push for the acceptance, get the proposal approved. And look, decentralization is great, but for wider adoption and industry, it's not the most ideal. So what needs to happen then is, once it's approved, it needs to be added to an improvement proposal, EIP, and that can take about a year and a half to actually get put in place. So if you're a business looking to scale or looking to operate or looking to adopt this technology, you don't want to be waiting a year and a half. So with Avalanche out of the box, you can basically deploy your layer one. And as mentioned, you can have all of that customizability out of the box. So you'll have it straight away. So you don't need to wait, you don't need to propose, you don't need to do anything along those lines. From a business perspective, and let's say move fast and adopt, Avalanche has ticked all the boxes there. So as you can see, our smart contracts, not only Solidity, can be written in Rust, Move, TypeScript, other languages. So the execution is EVM, Move EVM, Wasp EVM. That's the Rust compilation, and then the consensus is still managed by Avalanche. So you don't have to worry about if you're deploying on Avalanche and you want to write in Rust or anything like that. You're gonna be worrying about a different consensus mechanism. It's all housed under the Avalanche consensus, which is really great. So some of the benefits. So looking at the benefits of Avalanche, so you have reduced deployment costs. So previously deploying a subnet on Avalanche required staking 2,000 AVAX tokens. So as part of the Etna upgrade, that has decreased dramatically. So the Etna upgrade replaces this with a dynamic fee structure, so significantly lowering the initial costs by over 99.9%. This reduction makes it more accessible for businesses to launch their own layer one blockchains on Avalanche. So I believe it's about 2, 3 AVAX or something like that a month. It changes, but if you're just deploying, a test net, there's not going to be no cost. But what I would suggest is, if you do deploy a test net, build up your application on top of it. You can write your contracts in Solidity if you're already native to Solidity, and you can deploy it on the testnet. And as your business or your project grows, get in contact with myself or get in contact with your lecturers, who can get in contact with myself, and I can put you in contact with the Avalanche development team, or we can look at different competitions that you can enter and with your application. So then enhanced customization and sovereignty. With Etna, companies can create sovereign layer one blockchains with tailored validator management, staking mechanisms, and compliance features. This flexibility allows businesses to implement custom validator logic, enforce geo restrictions, and adhere to specific regulatory requirements, providing greater control over their blockchain operations. So then we have improved interoperability. So the upgrade introduces Avalanche interchain messaging. So Avalanche is multi-chain, so we can pass messages from chain to chain. So that I'll provide some resources where you can learn more about that in depth and how to actually send messages across chains. Avalanche also has a Bitcoin innovation around messaging, so that's quite interesting to research as well. So ICM, which is the Avalanche Interchain messaging, facilitates seamless communication and asset transfers between different blockchains within the Avalanche ecosystem. This interconnectedness enables businesses to leverage, share liquidity, and interact effortlessly with other networks, enhancing the utility and reach of their applications. So then cost-effective and scalable transactions. Avalanche's architecture supports high transaction throughput with low fees. The Edna upgrade further optimizes transactions costs, making it a cost-effective solution for businesses requiring scalable and efficient blockchain operations. And then compatibility with Ethereum. Avalanche maintains compatibility with Ethereum's virtual machine, the EVM, allowing companies to utilize existing Ethereum developer tools and smart contracts. This compatibility facilitates a smoother transition for businesses considering a move from Ethereum to Avalanche, reducing development time and costs. So, a quick look at the Avalanche consensus. There's a quorum. So you'll have preference of Bob. So we'll just bring this in as well. Just kind of define some of the letters you'll see here. While not decided, so let's say consecutive consensus is 0, and the preference is Bob. So while not decided, ask K random people their preference. So K is a sample size. So you might have 10 or 8 as the sample size. So if greater than or equal to A is the quorum size. So how many of the Ask participants have to have the same preference for me to change my preference. So if greater than or equal to A, give a sample response of the preference. And then you have a response with greater than or equal to A. Again, so if the preference is equal to the old preference, iterate, or else consecutive successes is 1. So basically, if the preference is not equal to the old preference, or is more than, if there's a quorum or consensus within that, you'll get the consecutive success, or else the consecutive consensus 0. If the consecutive consensus is greater than the decision threshold, so how many times does the quorum have to confirm my preference until I finalize my decision? So then you'll have your output, or you'll have your decision. So basically, it's a sample size, and it's got, let's say you've got 10 validators. It's a majority, but there is an iterative process in there. So if you don't have let's say if you don't have a decision threshold within the quorum size, or within the sample size, you'll iterate again, and it'll go again until it has that consensus. So that I'll be able to share this, and this is again going to be available on the Avalanche documentation. So looking at scaling, so we looked at this short analogy earlier on. So you have subnet A, subnet B, subnet C, and subnet D, layer 1s now. So creates many specialized chains, and you're going to have varying transactions costs, varying security guarantees. So Avalanche allows for all this to be wrapped in. So you're not going to have varying transaction costs. You're not going to have varying security guarantees. It's all encapsulated within the Avalanche consensus and security of the chain. And as mentioned previously, the transactions costs are set to be predictable, and not congested. So really with this, so if you have a lot of transactions, let's say coming through this chain here, it's going to offset some of the transactions to subnet B, and then if this is getting congested and this is getting congested, it's going to offset transactions to C and D, etc., and so forth and so on. So that's what allows for the high transactions per second. So then looking at permissioning, so we have the validators, smart contract deployers, and the users. So Avalanche allows for a number of permissioning capabilities, which in turn can work to ensure KYC and regulatory standards are adhered to. An example of this would be customizable validators. So layer ones can specify which validators are allowed to join, as mentioned previously. So with the GDPR and allowing validators in specific regions, for example. So you might have a specific again, medical records for example, in Kerala or India, or you might want to have only validators within Kerala. So you could say, okay, we only want people within Kerala Blockchain Academy to be validators of our network. And so you can create a layer one with those addresses of those people and permission those people to only be validators. So a small project you could do would be to create a layer one with only your class as validators, and then have everyone run that network. So you would have independent governance. So each subnet can have its own governance model, enabling tailored decision-making processes. So within that, you could then have your own governance. So create your own governance. What do you want to achieve with that? So then looking at access control, whitelisting, only pre-approved nodes can join the network. So again, with that permissioning, you would have your whitelisting of each individual, let's say in your class. Role-based permissions, different roles, e.g. admin, user, auditor, can be assigned specific permissions. So again, you could allocate an admin within the class, if there's a class rep or a class president or something along those lines, and then and so forth and so on downwards. So then you would have smart contracts. So access control logic can be embedded in smart contracts. So you can actually code that into your smart contract. You could say, if class rep A isn't available, revert to class rep B for permissioning, or for allowing asset to token creation. If you're saying message.sender is user A, you can say, right, okay, if that's not available, we can use user B. So then compliance in Avalanche, KYC AML as mentioned, hugely important. So we have identity verification. So validators and participants can be required to undergo identity verification before joining. So you could integrate some type of, if you really wanted, like an OCR maybe, or you could have image recognition, and you could also, if you wanted to go a layer deeper than that, your digital identity. So you could create a token similar to, you might have a JWT token, or you might have a token associated with a user. You could associate that then on chain, or an NFT associated with that. So as proof of identity, with some type of way to verify that person. I know other chains have used biometrics. Might be a bit of a big ask, but it's you could do a video capture, for example, store that on chain, hash it, compress it, and then that's your verifiable, and then you can decode that to confirm. Transaction monitoring. So smart contracts can be used to monitor transactions for suspicious activity and enforce AML rules. And then, as mentioned, GDPR. So that's quite European specific, and that's just around how data is managed and processed. So look, with Avalanche specifically, we have high throughput, low latency, security, and flexibility. So Avalanche can process thousands of transactions per second. This is achieved through parallelism, where parallel processing of transactions across multiple chains is achieved. Compared to other blockchain platforms like Bitcoin and Ethereum, which can handle roughly 7 and 30 transactions per second, Avalanche's ability to process thousands of transactions per second positions it as a leader in terms of transaction throughput. Low latency, transaction finality within seconds. So the consensus speed, the Avalanche consensus protocol is designed for rapid agreement among nodes, and typically achieving transaction finality within 1 to 2 seconds. This is significantly faster than many other blockchain networks, where finality can take minutes. User experience. So user latency ensures that users and applications can operate smoothly without waiting for long confirmation times, making Avalanche an attractive choice for real-time applications, like point-of-sale systems and high-frequency trading. And again, Martin Eckert gave the example of, if you're trying to bring on NASDAQ onto a blockchain, or the Indian Stock Exchange onto a blockchain, you need this quick. You can't have waiting an hour for a transaction to finalize, or waiting 20 minutes. It needs to be rapid fast. So Avalanche is allowing for this, and we anticipate scaling even further. Or it's been worked on at the moment. So decentralized consensus. Avalanche's consensus mechanism is designed to be highly resilient against attacks. It leverages a probabilistic model that ensures all honest nodes agree on the same set of transactions with a very high probability, reducing the chances of forks and double spend attacks. So double spending attacks, if you're not aware, are where somebody will submit multiple transactions with using the same funds to try to break the chain or to try attack the network. And then safety guarantees. The consensus protocol provides strong safety guarantees, meaning that once a transaction is confirmed, it is final and cannot be reversed. This is crucial for maintaining trust and security in financial and other centralized or critical applications. So then flexibility, support for multiple custom virtual machines. As mentioned, multiple EVMs can be used, and if you are interested, the let's say Avalanche development team is looking for people to create EVMs to interact with the chain. So if you were interested in taking on a project or investigating or researching, you could look at a base EVM to Avalanche. You could look at a Solana EVM to Avalanche. You could look at Polygon EVM. These could be out there. You'd have to do a bit of research. You could look at lots of any other chain that's out there, like for example, Moonbeam, for example, to Avalanche, or any other chain that you're aware of. You might know chains they're popping up everywhere these days. So then subnet or layer one customization, Taylor network. So Avalanche allows for the creation of layer ones, each with its own set of rules of governance and structures. So this enables organizations to create permissioned or permissionless networks tailored to their specific requirements. And then interoperability, layer ones can interoperate with each other, allowing assets and information to move seamlessly across different parts of the Avalanche ecosystem. This enhances the overall utility and functionality of the platform. So Avalanche has three chains. Mainly you would use the X chain, which is basically the exchange chain. So it's the or yeah, you could use any chain really. The P chain, the platform chain, the C chain is contract chain, so probably actually you probably more interact with the C chain, just because that's the contract chain. If you're writing smart contracts, that's probably the best chain to use. X chain is if you scale up. So if you develop an application that you want to have more resource available to, X chain would be the one to go to. So just think of it, X is the exchange chain. Exchanges do a lot of transactions. So you might have the likes of Trader Joe, for example, on Avalanche. There is also a separate chain or a separate exchange that is used. Yeah, I'll provide the information at the end. But that they would use, or if any of the exchanges were using Avalanche, they would use the X chain. C chain would be the contract chain. So if you're interacting with smart contracts or writing smart contracts, again, you're going to be deploying it to the C chain. And then the P chain is the platform chain. So that would be for large scale platforms coming onto the Avalanche network, and be specifically designed to take on that type of throughput. Yeah, so that kind of gives an overview of that. So layer one deployments. So as mentioned previously, the Etna upgrade provides a new way for validators and staking to interact with the chain. So the previous model had created a significant economic barrier for the creation of new subnets as validators, as they had to meet previously 2,000 AVAX. So, 2,000 X, I think Avalanche is about $40 at the moment. You're talking 80,000 euro, which isn't, it's just not like, I don't know, you want to be in early or, deep pockets to be able to associate with that. So that's the economic barrier. So that was identified as an issue to getting people on board and becoming validators and creating their own layer ones. So that 2,000 AVAX requirement, and a majority of subnets prefer to run with a maximum of 5 validators, right? So so think 80,000 euro by 5, you got 400,000 euro. So you're not, it's not like yeah, to actually set up a company or to run on that, it's challenging. So the Etna upgrade will remove this requirement for layer 1 validators to validate the primary network and fulfill its staking requirements. Therefore, they do not need to stake 2,000 AVAX on the primary network and instead only abide by the staking requirements defined by the layer 1 they wish to validate. So you can have, for example, a layer 1 which might only be 100 AVAX a month, making it a lot more achievable for somebody to come in. And the staking requirements, as mentioned, are defined by the layer 1. So if you create a layer 1, you can, set your own rules on what what the limit is or what the amount is. So it creates a much more dynamic layer 1 creation and adoption method for individuals. So again, I'll provide more information on this, but Etna drastically reduced the amount of AVAX required for a validator to actually run on AVAX. So, mentioned previously as well, cross-chain communication. This is a very brief, high-level overview of how that works. So you'll have your source chain, your destination chain, your message, and the proof that that event occurred. So, think of these as independent chains. So within the Avalanche ecosystem, think of, this could be Ethereum, but it's, just a regular layer 1 somebody's created within Avalanche. And this could be, Arbitrum. Arbitrum's the layer 2 on Ethereum, but this could be Moonbeam. But this is just a separate layer 1 within Avalanche, and you can actually communicate across chains within the Avalanche ecosystem. So you have the proof that the event occurred within the message, so you're able to create that cross-chain communication within the Avalanche ecosystem. So the next example I'll show you here, you would have disregard subnet, they're layer 1s. So layer 1, so you have a bank layer 1. So coming back to here, same thing. So you've got your layer 1 of a bank, you've got your layer 2 bank 2 here, bank 2. And 3 here. So you can send, let's say if you're doing foreign exchange, for example, you can send transactions or euro from here to here, swap Japanese yen to euro, swap pounds to euro, swap USD to Japanese yen. So it allows for this interoperability and interconnectivity between all the chains within the Avalanche ecosystem. So if you want to provide liquidity, for example, so if you each classmate has a layer 1, for example, and you want to start transacting between each other, that's very, very, very straightforward. And we have examples within GitHub repo that I can share at the end of this to kind of walk you through it. The documentation on Avalanche is rich. There's a lot of documentation there. And for anything else, we have a very active community on Telegram and Discord that can answer any more technical questions or niche questions that might prop up. Excuse me. So then looking at VM customization. So we'd have changing parameters of an existing VM, does not require coding. So as you'll see at the end of this, I'm going to go through a little layer 1 creation. So for VM customization, changing parameters of an existing VM does not require any coding. It can all be done through the CLI. VM modification. So extending an existing virtual machine through plugins and precompiles does require coding. Sorry now. So if you want to add anything to an EVM, or if you want to, update the VM to your specific needs, you will require a little bit of coding for that to be in place. And then creating a completely new VM from scratch or with an SDK requires coding. So this is, as I mentioned, if you wanted to create a VM for Solana, or if you wanted to create a VM for another chain, you're going to require coding there. Kind of complexity increases here as we iterate here. So you've got very little code, no coding, small bit of coding, a bit of coding required there to put in your precompiles and plugins and documentation, and then a lot of coding obviously to create an actual VM. But quite a rewarding processor, if you were to create your own EVM, you could create fees associated with that, be a revenue generator as such if people were using it. So, yeah, it's a nice use case. And then some real world use cases. So we'll go into some examples here of, if you were considering working with Avalanche or adopting Avalanche as a blockchain, what you could do or what has been done using multinational companies. So here we have Tide at Shopify, e-commerce and loyalty store. So the community-powered loyalty solution Tide uses an Avalanche-powered platform to reach millions of merchants through Shopify. Armed with Web3 capabilities, the Teeb app lets Shopify merchants reward their fans in new ways for posting to social media, writing reviews, making referrals. Deloitte, large accountancy firm, they use Avalanche for the disaster relief. So Deloitte manages FEMA public assistance payments to state, local, and non-profit actors, providing relief following natural disasters, a complex and difficult process. So again, there could be power down, there could be other issues associated with disaster relief, but Avalanche provides the services to Deloitte to provide that. Lemonade, an insurance provider. I actually studied Lemonade myself as part of my MBA, which is when I saw this, I was like, oh, that's really interesting. So that Lemonade is let's say a cloud native or very automated insurance provider in the US. So they look to reduce premiums through full automation. So they'll use a lot of AI algorithms and they'll use a lot of machine learning to automate the process of claims within insurance. So the dynamics of insurance make it hard for some people to get coverage by automating a policy using an oracle to track whether the smart contracts to track weather and smart contracts for payments. Lemonade provides crop insurance to small farmers in Kenya with an Avalanche app. It's really interesting, yeah. So, Gonzilla then gaming. Avalanche is quite big in the gaming scene at the moment. You might have seen Off the Grid. If you're following Twitter, Off the Grid it's kind of like a Fortnite-esque game. But it's all on blockchain. It's all on Avalanche and Avalanche. The fact that, as mentioned, high throughput, short time to finality allows for a really robust gaming experience. All on chain, which is amazing. And it shows to the how the technology has evolved. Excuse me. And then Entain, which is structured finance, so transparency, liquidity, and efficiency limit the multi-trillion-dollar structured finance market. Striving to improve this market, Entain has launched Entain Markets, a marketplace for tokenized assets on the Avalanche ecosystem. So, and then further, so examples you could look at is asset bridging, tokens, NFTs, DeFi, DAO, voting across chains, cross-chain liquidity, gaming, charity, finance, and insurance, all industries or areas that you could easily jump in and create an application for. I myself have built applications in the previously associated with finance, cross-chain liquidity, asset bridging. So really a lot of scope to develop applications if you were so interested in that. So what I will ask then next is here is Core Wallet. So if people want to scan that QR code, that will bring them to the Core Wallet. If they like, they can download this, which allows users to interact with Avalanche. So it's a browser extension similar to MetaMask, and that will give you the ability to develop within the Avalanche ecosystem. Everything costs gas, so you'll have to pay for fees with gas. So again, if you can't take this down now, if you can't get this now, I will share relevant information later on, and that can be shared out if you are interested. And then the Avalanche starter kit is here. I will also share a link to this in the chat. Let's go back here. Chat. So here's the starter kit. So that will allow you to really get up and running on Avalanche. And I'll go through a short intro in a second just to kind of show you how straightforward it is. So what you would need for the starter kit is Docker, VS Code or Gitpod. Uh, Foundry. I find you don't really need Foundry, but you can use Foundry if you use Foundry, and the Avalanche CLI. So let me just see if I can share info on the Avalanche CLI. Yeah. And then this is the Avalanche Academy. So the Avalanche Academy is a really interesting, let me just get here. Let's see, like commands. Yeah. So the Avalanche Academy sorry, has lots of courses. So you'll have the Avalanche Fundamentals course and you'll get certificates from this as well. We'll go through the fundamentals of Avalanche. Then you'll have multi-chain architecture. You can do another course on that. Again, they say an hour. It's a little bit more than an hour and a little bit more than an hour and a half. 3 hours. Quite complex ICM interchange messaging, but really robust information there on how to achieve interchain messaging. And then I say it's an hour, but an hour 1.5. But then, if you're writing code and you're kind of trying to follow along, it's going to be a little bit more. That's why I say that. But you could, if you were just interested to learn, you could do this in an hour and a half. There is tests and stuff like that in there as well, like just, multiple choice. And then interchain token transfers, customizing your VM, layer one token economics, Chainlink on your layer one, so we can actually integrate with Chainlink. So you can get oracles, you can get cross-chain asset transfer, things like that. So some really good documentation here, and not just documentation, courses that you can learn how to actually develop an application or a dApp on Avalanche. So I would encourage everyone to to look at that and the starter kit. So let's just have a look here. Can everyone see my terminal?
Yes.
Okay. So let me just double check this. So using the Avalanche CLI, we just say Avalanche create Avalanche Blockchain create, and we'll give it a name. So let's just say Kerala test. And you're gonna get this this.
Carl, I think we are still in your GitHub this website.
Oh, can you see my terminal now?
No. Terminal we can't. It is
You
moved
can't?
to yeah.
Okay, so sorry, let me just stop sharing here. And I'll share. Oh yes, here we go. That's what we want. You can see that now, yeah?
Yeah, yes.
Okay. So, using the Avalanche CLI, you would put in Avalanche blockchain create, and then you'll give the name, Kerala test, for example. So this would be the command. And then once you press enter, you'll be given the options here. So which virtual machine would you like to use? So you can kind of go through these. So you'd have, let's just say, a subnet EVM. And as mentioned, going back to how the layers of or the amount of coding required. So no coding required for just a subnet EVM. For a custom EVM, you would need a little bit of coding. There are options also with the custom EVM, so it will ask you, like whitelisting, KYC, things like that. But just for the ease of this presentation, we'll go with the subnet EVM. So, which validator management type would you like to use in your blockchain? So, proof of authority, proof of stake, explain the difference. So, let's just have a look and see what they want to explain the difference. Well, let's say proof of stake. Get address from an existing stored key created from Avalanche key creation. Yes. So, yes. Which stored key would be used? Which stored key should be used? Enable as controller of validator management contract. So let's say the EWOC, CLI teleporter deployer. Teleporter is a little bit more complex, but all of this is in the documentation that we can go through. And then I want to use the defaults for a test environment. And then I want to use defaults for production. I don't want to use default values and then explain the difference. So let's just go with the defaults. Chain ID, 123, token symbol, you know, Kerala T. Lovely. So then, we're going to need to run another command as per the documentation. So let's say, do we want to deploy? So local network. Okay, let's run a quick command. There we go. So you can see we've got a subnet ID, VM ID, blockchain ID, chain name, Kerala test. And you'll get some more PC endpoints. Brilliant. So as you can see, it ran through a number of automations. So there's a script there that we just can interact with using this command. So first of all, what we did was we created our Kerala testnet, subnet, proof of stake, and then I want to use the defaults. We gave it a chain ID, we gave it a token symbol, and then we created that. So then once it was created, we have to deploy it. So we just run the deploy command via the CLI, and then we have deployed it to the local network. It deploys using this hash, and then we come and we have at deployment. So it used this amount of AVAX, and then it created the chain with a separate fee. And we have the chain name of the Kerala testnet. We have subnet ID, VM ID, blockchain ID, and then we have convert subnet to layer one. So it just ran, as mentioned, Etna allowed for it to become a layer one rather than a subnet. So that's what it was running. And then it does some checks if the node is healthy. Working successfully tracking Kerala test. Node is healthier after 0 seconds. Proof of stake validator management contract successfully initiated. Layer 1 is successfully deployed. And then, as mentioned, we have an RPC endpoint here that we can interact with. It's using the local 127. I'm using WSL in Ubuntu. So it used This was the what we're using here, and then we have some relevant information that it provides us. So this will provide the same to you when you run this command. So you'll get all your relevant information, your VM ID, version, proof of stake, chain ID, subnet ID, everything from previous, the RPC endpoint, your ICM message, interchain messaging address, your token name, your token symbol, address and private key. Don't rob me. But you've got your amount of the Kerala token with 1 million tokens. You can do airdrops as mentioned to that, and then you're going to have some other smart contracts information, and then your precompiles, configs. As mentioned, we didn't do any of them, so there was not much there. Primary nodes, you're going to have node 1, 2, layer 1 nodes, your relevant endpoint for those nodes. And then you're going to have the wallet connection, your network or PC URL for the wallet, chain ID, token symbol, etc. And there's much more information that you can get. I'll share this in the chat so you can all do this. It's all part of the academy. So really, what I would suggest is to do the academy if you're interested, and you can create your own layer 1. You can interact with that layer 1, and you can really learn a lot more around the architecture and ecosystem by engaging with that. So let me just come back here. Yeah, and then if you want to get involved with us, our Irish Telegram and Twitter information is here. I think this goes to our Telegram. Let me just go here. Yeah, that goes to our Telegram. So if you're interested in getting involved, now I think there is a Kerala specific Avalanche crew of people. So I can share that information for the Kerala specific either WhatsApp or Telegram with people later via our chat. But you feel more than welcome to join the Irish Telegram as well. We have a lot of events going on and we have a lot of info. So either or is fine. Oh, excuse me. So thank you. Then that'll wrap me up. I hope you've taken a lot from that. And I'll take any questions.
Yeah, thank you, Carl. So we are all over to the questions. Participants can either unmute yourselves and ask the questions, or if you're finding any difficulty in unmuting yourself, you can just paste your comments in the chat.
Or if look to save time, if people don't have anything, if they want to email me, feel free. Or if they want to reach out on Telegram, or as part of the Irish Telegram, feel free. I'm happy to give my email. If people want to get in contact, I can share that. Or if they want to go between the lecturers and myself, that's no problem either.
Hi, Carl. This is Dilip.
I
The session was really good. Thank you so much for that. You have talked about few use cases like gaming, insurance, and other things. So my question is, this Avalanche blockchain or platform, is it compatible for real world asset tokenization?
Yeah, and as mentioned, we are off the grid is already an example of a game that's launched on Avalanche. So off the grid gaming on Avalanche. So they already have deployed, and they have assets that are already being used. So
Like tokenization of real estate, tokenization of
yeah,
gold, bonds, all those
yeah,
things.
yeah. It's possible. I don't know of the specific projects that would do that, but definitely it is because, as mentioned, we have. You can tokenize that through the Oracle. So say for example, if you wanted live price updates for gold, if you wanted live price updates for a house or real estate, you could get that technically through off-chain oracles, and get that live price feed coming in. So you could say, right, okay, my smart contract is tracking the price of gold, this asset, and this is how I interact with this, and that's how I'm going to track the price.
Okay, yeah. Thank you, Carl.
No problem. And that is available on the here. You would be best looking at Chainlink on your L1 via ICM. So Chainlink would
Okay,
be the
yeah.
oracle where you're going to get your price feeds from.
So all these courses are free courses that you
Free.
are offering, right?
Yeah. And you'll get a cert at the end. So course completion certificate, congratulations, and you can generate your cert with your name. That's only available once you've done all of them. There is tests, for example, in here as well. So you'll have to do, etc., to do that.
Yeah. So during the session only I have visited your academy page, so it was good actually. So we can get the certification also, right?
Yes,
Okay, yeah. Thank you, girl. Yeah.
no problem.
Any more questions from the audience?
Hello, sir. Am I audible?
Yes.
Sir, is there any native cryptocurrency in this network?
Pardon?
Is there any native cryptocurrency in this network?
For Avalanche?
Yes, sir.
Yeah, AVAX. So AVAX is top 10. Well, I think maybe 11th at the moment. So AVAX are 11th at the moment, just below Tron. There, $35. So yeah, AVAX. It's number 11 on the top 100.
Okay. Thank you, sir. Thank you.
Never.
So Carl, there is one question from the YouTube chat here. That is from Anju, who has asked a question that's what roles does Avalanche sees itself playing in creating a more interconnected multi-chain world?
So that's the primary goal of Avalanche. So as mentioned, Avalanche wants to create a more interoperable blockchain ecosystem. So they see heterogeneous blockchains, not just one chain to rule them all, let's say. To give a Lord of the Rings example, but they provide multiple chains. They envision, let's say, Optimism, Arbitrum, Avalanche, all these chains being connected and being able to scale using each other. And then Avalanche internally within Avalanche's ecosystem has multiple chains itself, or multiple layer ones that can scale also. So to be able to adopt this technology, we need to be able to scale to compete with the likes of Visa and MasterCard. So scalability, interoperability, and permissionless or permissioned, let's say, the ability for that for industry and industry to be able to come on board. So they're focusing on industry specifically rather than individual users as such, because industry adoption is where we need to get to. So to enable more transparent financial services, for example, more transparent data transfer. We need public ledgers to be adopted by industry, and that's really where Avalanche sees itself as positioning itself. Now, in an ideal world, we would say, all governments should be transparent and all businesses should be transparent, but that's not realistic. Businesses operate in methods they shouldn't. Governments operate in ways that are private, private banks, etc., and things like that. And not everything in the world we live in can be transparent. And Avalanche are aware of that. It's not a libertarian-esque approach, but to be able to take on as much industry as possible to enable transparency and create a more robust marketplace, I think, is Avalanche's main goal. I hope that answers that question.
Yeah, thank you, Carl. Yeah.
Uh,
Is there any question ahead?
Yeah, hi, hello. I have a question. Am I audible?
Yes, please
Yeah.
go ahead.
Yeah. So my question was, what are the challenges does Avalanche face?
Pardon?
What are the challenges does Avalanche face in its growth and adoption?
The challenges. So some of the challenges, I guess, are adoption, really. It's bringing people on board to the chain. What we are trying to get at the moment is commits. So we want people to be developing on the network. So we want people building applications. We want people, putting forward proposals. As mentioned, we want people building EVMs within the network. So really getting people to be developing within the Avalanche ecosystem is one of the goals or the KPIs. The challenges would mainly be adoption. Everyone's struggling with that. Like Avalanche has the scalability, it has the interoperability, it has high throughput, time to finality, things like that. So it's addressed a lot of, let's say, the trilemma, the blockchain trilemma. It is decentralized. Like the more validators you have on board, the more decentralized the network is. That the challenges I think is really or the focus is getting people on board to develop and build out applications on the network, because the more people that build, the more validators there are, the more people that it's a kind of a self-fulfilling prophecy. The more people you get on board, the more robust the network. So that's one of the challenges, or that's what we're looking to achieve.
Okay, so we'll take up one more question, which is in the chat. Before that, a gentle reminder to all the participants. We have already shared the feedback form with all of you in both. It is available in both the Zoom meeting platform as well as in the YouTube live chat. So you can just fill the form and you can get your feedbacks, and then we can issue you your blockchain powered certificate. So the one question here is, what strategies can be implemented to mitigate the risk of 51% attacks on smaller blockchain networks?
So what you'd be looking at is, so 51% attacks, really you're talking about proof of work more so. Proof of stake, yes, if you've got a lot of money in the network, or like a lot of tokens in the network. But basically you're looking to ensure that no single miner or group of miners or a mining pool is controlling more than 50% of the network. So what you can do to mitigate that um, really depends on your consensus and how you want the network to be managed. So it varies across chains. Basically, a 51% attack on Bitcoin, for example, you could say, if somebody's got all these data centers and they're processing to work against that, that network, that they technically could achieve it, but it's very unlikely. On smaller networks, that's a risk. Smaller network, and it's something that we've seen a lot. Is, let's say, for example, with I think, was it Ethereum Classic got 51% attacked a little while ago. One of the small, these kind of ghost chains where look at Feathercoin, look at Pink Coin, look at any of the coins that were back, back in 2015, 2014, when blockchain was just taking off, that are, no longer being used much anymore. And there's not many validators and there's not many miners. Somebody could, with a bit of resources, go in and manipulate the ledger. Luckily, the more people that use a chain, the less likely an attack like that is. So, for example, with Avalanche, it's going to be very, very difficult to actually implement a 51% attack. But as you mentioned, with the smaller chains, more open to that type of attack. But look, if that type of attack happens, they can change their strategy. I hope that answers that. I actually have to jump off now just at 10, if that's okay. But how can Avalanche be helpful in supply chain management and traceability for smaller businesses? So Avalanche will allow for fast transaction speeds. So like with supply chain management, you're looking for relevant information to be processed. Let's say your information is coming from China. You've got let's say you've got a tanker, and on that tanker you've got a bunch of cargo going from the UK to China, for example. You want that information to be fast. You want that information according to, and you've got all that information. Let's say you've got one container on that, or you've got one, whatever you call them, like metal box full of stuff on the tanker, and all the items in that box are itemized, so you have like 1 to 1,000. You need all that information to be processed fast, so you need to be able to get all those items in a transaction, and for that time finality to be processed quickly, so that if something happens within that supply chain from A to B, you know about it, and let's say your insurance provider knows about it, and you can say that this is true and factual, and you're not waiting an hour or two or for that transaction to be processed. So the interoperable sorry the high throughput and time to finality of Avalanche is what allows for, say, for example, a supply chain management and traceability to be implemented on Avalanche. And it's a good idea. It's something that you could look to integrate or create. You could just have your backend database on Avalanche, and have an NFT for each item. So each item that's generated, you could have a scanner. You could create an NFT for each item, and then each item would be tracked then as part of your traceability.
Okay. Carl, there is one more question in the personal chat for us. That was about the ambassador position. So many of the students have inquired about this ambassador positions, which is available, which has been of much of popular in Avalanche. So could you just give a brief about it?
Yes, so we just ran another cohort there recently around the ambassador positions. So we do run them every now and again. Follow me on Twitter. So my Twitter handle is let me just see here now. Follow me on Twitter, follow me on LinkedIn. I will share this stuff. Oh, how come I'm not? Let's go. Where's my profile? So follow me on Twitter, LinkedIn. And I post regularly once there's updates. And join the Avalanche Ambassador DAO as well on LinkedIn, or sorry, on Twitter. The Ambassador DAO. Because they will post regularly when there is openings becoming, and we're growing this. Avalanche, the foundation, I think gave us like 1.3 million recently to kind of work with initiatives as part of the DAO. Ambassador DAO, yeah, here we go. And as mentioned, we do have people in Kerala. So the best point of call would be to contact them. I'll get that information. I'll share that information with the individuals, and the lecturers can share that information with the students, if that's okay.
Okay, thank you so much, Carl. We'll ensure that. Sorry for your this delay, but thank you
No
for
problem.
your time, and we are immensely grateful to you for arranging this session with us. And thank you so much for your expertise and information. It was quite insightful. That was a great presentation. Also, you took us deep into the deployment of this network itself, and we got so much information from this session. So we wish you all the best for all the ventures, and we seek your expertise in future events to come. So thank you once again.
Thank you so much.
Thank you for the audience for joining with us. So do subscribe to our channel for getting notified about such events in the days to come. Thank you.
Thank you so much. Have a nice day.
Thank you.